List the different transformations you know and the information required to perform each of them. So this is transformations of objects that you should have seen previously. Hopefully you know about reflections. To describe a reflection, you need a mirror line or a line of reflection or a line of symmetry. And it will normally be given as an equation. So something like y equals 2 or y equals x. You will hopefully have seen rotations. Things you need for a rotation is a center of rotation. That is normally a coordinate, but it might be a point drawn. You need an angle or an amount of turn, which is normally 90 degrees, 270 degrees, or 180 degrees, and you need a direction, which is clockwise or anti-clockwise. A translation, which is moving it up and down and left and right. You need a way to describe the up and down movement and a way to describe the left and right movement. And normally we use a vector to describe this, a vector of the form AB, where the AB is the left and right movement and the B is the up and down movement. You might have come across an enlargement, which is when a shape is made bigger in all directions. For that, we need a center of enlargement, which is where we are enlarging it about, how much, the point that every point is getting further away from. And we need a scale factor. Scale factor is how much bigger it is getting. So 2 to get twice as big, or a half to get half as big. You may have seen this one, but you may not have. A stretch is the last type of transformation you might have come across already. Now, a stretch is similar to an enlargement, but it only happens in one direction. So if, for example, we have this triangle here, if we enlarge it, all the sides get bigger, and we get something like that. If we were to stretch it horizontally, then that side would get bigger, but the height would stay the same. So the height wouldn't get any bigger if we're stretching it horizontally. And if we were to stretch it vertically, then the bottom would stay the same, but it would be stretched up like that. So stretch is like an enlargement, but only happening in one direction at a time. To perform a stretch, we need what's called an invariant line. The invariant line is the line that we are stretching it from. So in this case, the invariant line would have been a vertical line because we're pulling it away from that vertical line. In this case, the invariant line was a horizontal line because we were pulling it away from that line. And we also need a factor, which is how much we're stretching it by. So again, this might have been a factor of 2 because it's getting twice as big. It could be a half if we're squishing it together. It could even be negative if it ends up on the other side of the line. So those are the 5 transformations you've possibly come across. I would expect you would have seen the first 3 definitely, probably the 4th one, the 5th one not necessarily.